Hey students, in this video we're going to continue learning about states of matter. So we already had one lesson about this where we learned about the characteristics of solids, liquids, and gases. In this video we are going to dive a little deeper and talk about changes between those phases of matter. So that's called a phase change. Okay. So first of all, I'm just going to start with the vocabulary. Okay. We know that we have solids, liquids, gases. Of course, there are more states of matter, but these are the ones we're going to cover in this course. And you can go between each of these states of matter, and it kind of forms a triangle like this. And each transition from one phase to another has a name. Okay, so let's start with the easy ones. From solid to liquid, think ice to water. Okay, we know that that's called melting. From liquid to solid is the opposite. Start with water, end up with ice. That's called freezing. Liquid to gas, there's actually two ways to do that. One is if you have a puddle out in the sun. That's the slow way, and that's called evaporation. The fast way is a pot of water on your stove, and that is called boiling. And the rest of these you may or may not know. These are the ones you most commonly encounter in your own life. Gas to liquids, you do see this happen a lot. Like if you go out on a hot day with a cold can of pop, you will start to see water droplets forming on the outside of that can. That's called condensation. Now the word condensation isn't just that. It's any time you take a gas, any gas, not just water, but any gas, and turn it into a liquid. That's the process of condensation. Okay. Now rarely, we don't see this very often, but in some cases you can start with a solid, like dry ice, for example, is the most common example. And if you heat up dry ice, it will not become a liquid first. It won't melt. That's why they call it dry ice, because if you heat it up, it goes straight to the gas phase. Okay? When this happens, that's called sublimation. Okay, so dry ice is solid carbon dioxide, and it sublimates. Okay? The opposite process can happen. You can take a gas and turn it directly into a solid without the condensation freezing in between. Okay, that's called deposition. And I'm going to run out of space to write this down, so I'm going to put it out here. Deposition. This is actually, and there's an interesting thing. You can make diamonds nowadays, and what they do, diamonds are made of carbon, the element carbon. They'll take carbon gas, so ridiculously hot, right? And you can get carbon gas to deposit onto a surface. And if you do that just right, it will make a diamond on that surface. That's called vapor deposition of carbon, okay? So here's our vocab words. You need to memorize these. They are going to come up a lot. And where we're going is we're trying to answer some bigger questions, right? Why do these things happen? What is actually happening at the particle level with these phase changes? So the vocab just gets us started. But let's talk about what's actually going on with the particles. Okay? So, main idea here. This is kind of the big idea of this whole unit. You see, when you have particles in a state of matter, solid, liquid, or gas, there's always this competition. And I might have talked about this in the last lesson, okay? Particles are attracted to each other, some more than others, but that pulls them together. At the same time, they want to move. They're always moving. They want to spread apart. That movement is what's trying to make them go apart. So there's a competition between those two. One force wants to bring them together. The other force wants to split them apart. Okay? And there's a constant competition there. So competition between attraction, and the fancy word here is kinetic energy, okay? Kinetic energy is the energy of movement, okay? So this competition can kind of tell us what's going on. In a solid, we know that the particles are stuck in place and they are moving, but the attraction between the particles in the solid is really strong. It holds those particles right where they are. In a gas, particles are moving all over. Obviously, they have much more kinetic energy than that attractive force keeping them together, and so they can move all over the container. Now, when there's a change in that balance, then you get a phase change, okay? So there's a competition between attraction and kinetic energy. Right, when there's like a disturbance in the force, if you don't mind me saying so, then we get a phase change. When there's a change in the balance. And kinetic energy, a phase change can happen. And this, I guess, is another vocab word. All those things we did above, boiling, evaporation, etc., those are all phase changes. So how do we get that change in this balance to happen? Well, the easiest way to do that is to change the temperature, okay? We can't really change the attraction between the particles. I mean, in rare cases, it's possible you can do chemical reactions to actually modify what the chemical is. But in general, particles are going to be attracted to each other, you know, a certain amount, and that's it. So we can't really change that. The kinetic energy, though, the movement of the particles, we can change that really easily, okay? Because temperature, so definition, temperature, a word that you thought you already knew what it meant, temperature is actually the average kinetic energy of the particles, okay? Temperature is how fast the particles are moving. So if we increase the temperature, the particles are going to move faster. Okay? Higher temp implies faster movement. And this just makes sense. I mean, think about it. If you have a solid here, particles are sitting there, stuck in place, they're bonded to each other really tightly. You heat them up. You know that when you heat up ice, it's going to melt. Well, what's really happening is you're giving those particles more kinetic energy, and eventually they have enough kinetic energy to break free of their places. They can move around. They're still touching each other, right? It's a liquid now, so the particles are still touching each other, but now they're not stuck in their place. And if you keep heating it up even further on the stove, eventually that liquid water is going to boil. The particles move faster and faster and faster in the liquid until they have so much kinetic energy they don't even have to be next to each other anymore. They totally break free of each other. And now you have a sample that's boiling, okay? So that leads us to our big questions. Why does melting happen? Okay, and I kind of already explained that, didn't I? Why does melting happen? Adding heat to the sample gives the particles more kinetic energy. Not cool. Alrighty, fire drill over, I'm back. Where were we? Adding heat to the sample gives the particles more kinetic energy. At some point, the kinetic energy is enough for the particles to break free of their fixed locations in the solid. Since they can move around, it's a liquid. And that's all there is to it. If you talk about this balance between kinetic energy and the attractions between particles, you can answer any questions about phase changes. Okay? I want you to go ahead and describe the process of boiling. Same game, talk about the particles, talk about that balance. Once you're done with that, right, come back to the video. I want to talk about this heat transfer one, but pause right now. Try the boiling one right now. Go ahead. Okay, so I hope that you used similar arguments for the boiling question. Heat transferring. I think students kind of have the idea that heat is some sort of magic thing that gets mysteriously transferred, but remember, heat and temperature, all it is the movement of particles. So when you have a hot thing, hot object next to a cold object, like you got a pot of water on the stove is hot, right? All that's happening is the particles on the stove are moving really fast because they're hot. And when they do that, they smash into the particles of the water and the pot, and that makes them go faster. So really all that heat transfer is the transfer of kinetic energy, okay? Since temperature is kinetic energy, heat transfer okay, so an easier way to say that is fast-moving particles smash into slow-moving particles, which gives the slower ones more speed, right? And if that happens enough times, then those slow-moving particles, eventually they're moving faster, and that's hotter, right? That's it, okay? So give these a shot. Why do some liquids evaporate faster than others? You know, what can you say about the strength of the attraction between the molecules in a liquid that doesn't evaporate very fast? It evaporates very slowly, right? That tells us something about how attracted those molecules are to each other. So I hope you enjoyed this, and I hope it helped you learn something about phase changes. Have a good day.